All right, so this will be the first probably several videos I make about force. So force should be, when you look at it, a fairly straightforward concept, but it just has, it seems like it has so many different components, and sometimes it can be kind of confusing. Now I'm going to just start off by saying that let's write down the basic force equation. So force is equal to mass times acceleration, which is the units for that would be kilograms for mass, and then acceleration would be meters divided by seconds squared, and then the unit for this whole thing would be in newtons. Okay, and then there's a couple of like little nuances with this. First of all, a lot of times, especially when we're talking about gravity, we would anything to do with gravity, we would remember that acceleration would be, mass times gravity. So if you're talking about something like weight, how much you weigh, you would just, we would calculate that by taking your mass times gravity. Okay, and so it's kind of the same equation there. And then acceleration, if you remember, is the change in velocity divided by time. But one thing to remember about this, and I kind of want to make a hint to some of my students about this, is that velocity changes without necessarily having a change in the speed. So remember that velocity is direction and speed. So if something is, say, circling, like say you're orbiting a planet, you might actually have a continuous speed, but because the direction continues to change, that gives you a change in velocity. So even though the speed remains the same, the velocity is changing. So there's some nuances there that we need to kind of keep an eye on. So anyway, let's go through and practice a couple of some of these basic questions that I have here. Maybe give us an idea. Now, another thing I'm going to suggest is that whenever you're doing a force question, you get in the habit of doing a free body diagram, and I'll show you what I mean by this. I prefer to do free body diagrams where I just use points rather than the like a block in this case, but I'm going to sort of set this aside, and this just kind of gives me an idea of what I'm looking at when I'm calculating this. So let's try this first one. The diagram at right represents a block at rest on an incline. So this is our block. It's at rest. It's at some unknown angle, but it's not sliding down, it looks like. So it's sort of staying put. And then we want to say which diagram below represents the force acting on the block. So we have, I would say normally when you're looking at forces, you have four basic forces you're looking at. You have the force of gravity, which is always coming straight down. You have the force normal, which is offsetting gravity, and that can be in different directions depending on the angle that the object is on, and I'll explain that in a second also. You can have the force of tension, which is something that's pulling on the block. You could just have a regular force, something pushing on it, so that's another option, which would be a little bit different. And then you'd also have the force of friction, which is what's kind of keeping the block from sliding down right now. So when I go through here, I'm going to draw a free body diagram, and to do that, I'm going to actually just draw a dot, and that will represent my block right here. And so I'm going to draw all the forces. I know for sure that on that block you have the force of gravity. It's going in this direction. It always goes straight down, force of gravity. Okay, now also you have some force of friction because the block wants to slide down because gravity is pushing it down. Even though it's at an angle, gravity is pushing that block down, but if it's sitting there and it's not moving, that means there must be something keeping it from sliding down to the left here, and that would be your force of friction. So there's enough friction on there that's keeping it from falling. Now, the other force that you always have, or almost always have when you have gravity, especially if it's sitting on something, is that you have the force normal. So gravity pushes something down, but the tabletop, or the incline in this case, is pushing it back up in that direction. The force of gravity always goes straight down. Force normal is always perpendicular to the surface that the object is on. And so since we have an angle like this, my force normal would be something like that, right there. All right. So this means that this the answer to this question would be number 4 there. So let's try one that's involves a little bit of math here. This number 4 here, and I'm going to draw a free body diagram to go along with it, but let's do a calculation with it. So a block weighing 10 newtons is on a ramp inclined at 30 degrees to the horizontal. So this is a block right here. It's on a ramp that's 30 degrees above the horizontal surface. A 3.3 Newton force of friction acts on the block as it is pulled up the ramp. So there's something pulling it up the ramp in this direction, but there's enough friction so it's kind of, you have the force of friction going in that direction. So that's playing a role right now in whatever's happening to F. And then the question is, what is the magnitude of force F? So I'm trying to find out what the number is for that. So since we're looking at this and we realize that this force that's pulling in this direction is enough to offset gravity and the force of friction, we really can just write something like this. We can say that our force is equal to the force of friction plus the force of gravity, okay? So all I really have to do is figure out what the force of friction is and the force of gravity, and I'll know what the force is moving in this direction. It would have to be a teeny tiny bit larger, but essentially we'll just set those equal to each other, okay? And that's a lot of times when you're doing these problems, that's really all you have to kind of focus on, is that you find the forces that are offsetting the force you're interested in, set one equal to the other, all right? And so we already know that the force of friction is 3.0, try that again, 3.0 newtons. And then we also know that the force of gravity is equal to mass times gravity, okay? But what's thing that's happening here, and I'm gonna draw a little free body diagram to show this, I've got force going in this direction, I've got force of friction going in that direction, I have the force of gravity going in that direction, and then I have this normal force, which is perpendicular to the table, going in that direction. So the other force that's holding against this is the force of gravity, but the force of gravity is going straight down, and this is on an angle. So one of the things I suggest you remember is that since we're looking for vertical here, vertical is pretty much always found by taking the sine of theta, okay? And so my force of gravity is going to be equal to 10 newtons, because that's what this is here. That's what's caused this mass on the block, is the gravity. And so that would be 10 newtons, but it's at an angle, so we're going to multiply that by the sine of 30 degrees. Okay, and this is a super common occurrence in this type of question, so watch for this always, where you're taking some sort of force and you're multiplying it by the sine of whatever your angle is, or sometimes the cosine, depending on whether you're looking at something that's working for gravity or maybe it's working for the force normal. So they have different components, but generally speaking, for gravity, we're looking for the sine. And so when I take that, I know that the sine of 30 degrees is 0.5, so that would be 0.5 times 10 would be 5 plus 3. This is equal to 8 newtons. And so in order for the force to move in this direction, to actually drag this block uphill, I would require 8 newtons of force in order to do that. Okay. Let's see, one other question here we want to look at. Let's try this question right here. This is the same thing except that it's missing friction, so that's kind of nice. A diagram below shows a 1.0 times 10 to the 5th Newton truck at rest, and that just means that's its mass times gravity, on a hill that makes an angle of 8 degrees with the horizontal. So it's on the slight hill here, and then we want to know what the truck's weight is parallel to the hill. Well, again, I'm really just looking for this. Remember, weight is the same thing as gravity, right? It's gravity times mass. And so I can say, I can take mg times the sine of theta. It's going to be equal to my answer. So my mass times gravity is given right here as 1 times 10 to the 5th, and then I'm going to multiply that by the sine of 8 degrees, and I end up with 1.4 times 10 to the 4th newtons. Okay, so right in here again, watch whenever you're doing these inclines, you always want to think sine of theta times whatever the normal force is here, which is causing this weight here. So, okay.